So when we plug into an equation, our first step is just put the equation into Desmos and identify our zeros. X to the fourth plus 2x cubed. Follow along with me on Desmos. Yeah, I'm gonna upload. But remember, it's just a supplement. It's not videos never no. What? Yeah, I mean, that's essentially what I'm doing right now. Yeah. Okay, so we have zeros at negative 0.49 and negative. Oh, did I Oh, is that x to the fourth plus 2x cubed? Oh, sorry. Plus here. Here's what I'm gonna do to make this problem work. Okay, I'm going to add a 10x squared to make this problem work. Okay. So change it so because I need this problem to function more similar to a midterm problem. To make the problem work with clean numbers. We can use x to the fourth plus 2x cubed plus 10x squared plus 18x plus 9. This is going to make the practice problem function a lot easier. And it's going to allow us to use whole numbers. So plus 10x squared plus 18x plus 9. I added that 10x squared in there so that the numbers that we're using are easier to identify. Yeah, this is just so now on Desmos, I have a real zero of -1. Yeah. But so x to the fourth plus 2x cubed plus 10x squared plus 18x plus 9. All right. So right now we just see our real zero, right? What's the 1, 0 we see? Right. Yeah, okay. So we have a 0 of 1. So let's first, our first step is to graph, all right? We graph in Desmos. We graph in Desmos and we see that we have a 0 at -1. Okay. Now does this at -1 do we bounce or pass through? Here we see that we hit the 0 and we bounce. So we see we bounce. So I'm going to say that's a multiplicity 2. We bounce, so that's multiplicity 2. Multiplicity 2. All right. When you have an odd multiplicity, you pass through the 0. The graph passes through the 0. When you have an even multiplicity, the graph bounces. It hits the 0, then it comes back up in the shape of a parabola. So we know the multiplicity is even because it bounces. And its multiplicity is 2 because 1, 2 is an even number. And 2, the graph bounces in the shape of a parabola. If it bounces in the shape of a parabola, it's multiplicity Yeah, the shape that it bounces is a parabola. Okay, so if our 0 is -1 and our factor is and our factor is and a multiplicity. Sorry, if 0 is -1 and our multiplicity is 2, what's our factor? For 0 is -1, what's the factor? X plus 1 squared. Okay. So now yes, so that's the power. So x plus 1 squared. What's x plus 1? What happens when we distribute x plus 1 squared? X squared plus 2x plus 1. All right. This is because this is x plus 1 squared is x plus 1 times x plus 1. So x times x is x squared. X times 1 is x. 1 times x is x. And 1 times 1 is 1. Yes, you factor it. You distribute. You expand the. Yeah. The fastest way I do it is I just do x squared 2 times 1 times x is 2x. 1 and 1 squared is 1. So I square the first term, I multiply the exponent, and then the 3 terms for the second 2, and the third term is x squared plus 2x plus 1. That's the answer? No. Okay. What I now do is I know that this is a factor, right? I'm expanding it so I can do division. Because I can find my other factors by doing polynomial long division. Okay? So I can do the problem x to the 4th plus 2x cubed plus 18x plus 10x squared plus 10x squared plus 18x plus 9. Okay? Then I divide it by x squared plus 2x plus 1. X squared plus 2x plus 1. All right? Why am I dividing? I'm dividing. Okay. Let's get back on task. I'm dividing because what I'm trying to do is divide by the factors that I know I have to find the other factors. Because in order to find all the polynomial in factored form, you need to find the other factors by dividing. Well, yeah, that this is right here x squared plus 2x plus 1. X squared plus, yeah, I picked a number to make the question work with a whole number for its zeros. X squared plus 2x plus 1. Yeah, I added that 10x squared so that the 0 of this graph would be a whole number. Now, what I do is I always pick x values that multiply with the leading term of my divisor to cancel out the leading term of the dividend. The dividend is the term under the division sign. So I'm going to pick x squared. Why? Because x squared times x squared is x to the fourth, and that will cancel out. I'm trying to cancel out the leading term. Because you all in polynomial long division, your next step is always to cancel out the leading term. Yes.
Is there a way you can play
So we can.
Oh, so Mr. Lau, focus on my question. So you have a square root bar, and then you're dividing.
This is not the square root bar. This is the division sign.
The line, are you dividing it again?
I'm in the process of doing the first step of polynomial long division. Can I continue with the first step? Yes.
I'm not good at dividing.
Okay. We have to. Let's get through the problems first. Okay. We have to get through the problem step by step. X squared times 2x is 2x cubed plus 2x cubed. X squared times 1 is x squared. Now take parentheses, subtract x to the fourth minus x to the fourth. 0. 2x cubed minus 2x cubed. All right, what's 10x squared minus x squared? What's 10x squared minus x squared? 9x squared. We bring down the 18x and the 9. Okay. Now, what is because x squared times 2x is 2x cubed. I take the term that I just multiplied by, I group it in parentheses, and I subtract. 2x cubed minus 2x cubed is 0.
And you put that over it to equal the x to the fourth power, and then you're multiplying that by 2x. Essentially.
I multiplied x squared by x squared to get x to the fourth. I multiplied x squared by 2x to get 2x cubed. I multiplied x squared by 1 to get x squared. Once, because I grouped this term in parentheses, subtracted down. Now, once again, I try to cancel the leading coefficient. What times x squared, all right, equals 9x squared? What times x squared equals 9x squared? Yeah. Yep. So I have x squared plus 9. 9 times x squared is 9x squared. 9 times 2 is, 9 times 2x is 18x, and 9 times 1 is 9. I group this in parentheses. It cancels out, its remainder 0.
That's the answer, 0?
So that's the remainder. So now what's my quotient? So my quotient is x squared plus 9, and I need to have this factored out. But this won't factor, so let's use we can use the quadratic formula if we don't know the complex conjugate theorem. So let's use the quadratic formula. This is x squared plus 0x plus 9. So using the quadratic formula, this is negative 0. So a is 1, b is 2, c is 9. This is negative b squared plus or minus the square root. Sorry. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's going to be 0 plus or minus the square root of 0 squared minus 4 times 1 times 9 all over 4 times 1 times 9, because a is 1 and c is 9, all over 2a, so all over 2. So this is going to be equal to plus or minus the square root of negative 36 all over 2. All right, and negative 36 is going to be, well, so, so it's 6, so it's 6, yes, it is 6i, because this has become equal to the square root, the square root of 36 is 6, so this becomes 6 times the square root of -1 over 2, which is going to be equal to 6i over 2. Note that I is equal to the square root of -1, which is equal to 3i. Well, and remember, our answer is equal to plus minus 3i. So if our zeros are plus minus 3i, our factors are x plus 3i, x minus 3i. Yeah. Okay, because you have the square root of 36, square root of -36, the square root of -36 is equal to the square root of 36 times the square root of -1. So -36 is equal to the square root of 36 times -1, which is equal to the square root of 36 times the square root of -1. Square root of 36 is 6. Square root of -1 is I. Yeah. So now I have two more factors, x plus 3i and x minus 3i. So now my factors are x plus 1 squared. This is the final answer. X plus 1 squared. X plus 3i. And x minus 3i. This is the factored form of the polynomial.
That's the answer?
Yeah. So if you had multiple choice, so this is the only way you do it if you don't have multiple choice answers. If you do, it is multiple choice. So I feel like this is the way to do it. This is the other way to do it if you do have multiple choice answers. All right.
Wait, so what's the other way?
Okay. So
I just want the name.
what you would have to do is for all of your answer choices with imaginary numbers, multiply out the imaginary numbers. So, for example, here, one of the correct answer choices was going to be, like, this would be a correct answer choice. So one correct answer choice would have been, here, let's open Paint. Yeah, I'm going to open book Paint. Okay, so it is clear that we have to do this for all the answer choices, but one of the correct answer choices was, so this is the correct answer, x plus 1 squared times x minus 3i, x plus 3i. So this is one of the answer choices. Now, what you have to do is for all answer choices with imaginary numbers, okay, what we would have to do is multiply the factors with imaginary numbers and then put those into Desmos and then see whether it matched up with our original graph.
Okay, so essentially what you can do is you can plug in the whole problem, the x to the 4.
Yeah, plus 2x cubed.
And then you can plug in each answer choice and see which one lines up.
But before you can plug this into Desmos, what you would have to do is simplify your imaginary factors. X times x is x, because this is x squared, plus 3ix minus 3ix, and then -3 times 3, phones away. -3 times 3 is -9, I times I is, what's I times I? I squared. Now, what is I equal to? Square root of negative 1. So what is the square root of negative 1 squared? Negative 1. So I squared is equal to negative 1. This becomes x squared. What's 3ix? What's positive 3ix minus 3ix? What's 0, right? And it cancels out. And then what's negative 9 times I squared, which is negative 1? X squared plus 9, right? So now you have x plus 1 squared, x squared plus 9. In Desmos, and you have to do this for each answer choice, in Desmos you would have to put in x plus 1 squared times x squared plus 9, and if it matched up with your graph, that would be your answer choice. Yeah.
That equation equals one of the answer choices exactly on Desmos exam.
Yeah, and what we, and I'll show you, so we can have x plus 1 squared. Let me see if we can do, if we can just enter in, well, if we can enter a 9. All right, so x minus 3i, sorry, and x plus 3i. Was that? No, yeah. Oh yeah, so what you have to plug into Desmos is you have to simplify multiplying your imaginary numbers into x squared plus 1 times x squared plus 9. X squared plus 9, and this will be equivalent to x to the 4th plus 2x cubed plus 10x x squared plus 18x plus 9. And now the graphs are equivalent.